Hello friends, now in this video I will explain exercise 5.2, all the examples from the exercise 5.2. But before exercise 5.1, you must know some concept regarding the exercise 5.2. I will explain all these examples and the basic concept for the exercise 5.2. Now let us start. First is a relation, and here is the order pair. A pair AB of numbers such that the order in which numbers appear is important is called an order pair. Okay. In general, order pair AB and the BA are the different ones. In order pair AB, A is the first component and the B is the second component. Okay. Now the is called the second component. Two order pairs AB and CD are equal if and only if A is equals to C and B is equals to D. Means the first component of these two are equal, second component of these two are equal. And also AB is equals to BA if and only when A is equals to B. Now the first example, solve example. Find x and y when x plus 3, 2 is equals to 4, y minus 3. Now the solution. Using the definition of equality of two order pairs, we have x plus 3, 2 is equals to 4, y minus 3. And here x plus 3 is equals to 4. And hence if you solve this, then you will get x is equals to 1. And what about here? 2 is equals to y minus 3. And if you simplify, take this 3 minus 3 to the left hand side, it will become plus. That is a 2 plus 3 is equals to 5. And hence y is equals to 5. Okay, x is 1, y is equals to 5. Now the next. Cartesian products of two sets means what? Let A and B be two non-empty sets. Then the Cartesian products of A and B is defined as the set of all order pairs AB such that A belongs to A and B belongs to B. Small a belongs to A, small b belongs to B. It is denoted by A cross B and read as A cross B. Thus the A cross B is equals to, in curly bracket, AB such that, order pair AB such that small a belongs to capital A, small b belongs to capital B. For example, if we have the set A and contains the two elements 1 and 2 and B, A, B, C, can we define A cross B? Yes, we can define. Now see this here, 1 to A, that is 1A, 1 to B, 1B, 1C, 2A, 2B, 2C. In this way, we have A cross B. Now here, note that if A is 5 or B is equals to 5, then what about their Cartesian product? A cross B is also 5. Okay. Now the next is number of elements in the Cartesian products of two finite sets. Let A and B be any two finite sets. Then n of A is equals to m1. Number of the elements in A is m1. N of B is equals to m2. That is the number of elements in the set B. Then the number of elements in the Cartesian product of A and B is given by n of A cross B is equals to m1 into m2, and that's nothing but n of A into n of B. Okay, now we see this example. Let example number 1, A is equals to, A is the set 1, 3 and B is a 2, 3, 4. Find the number of elements in the Cartesian product of A and B. Okay, now the solution. A is 1, 3, B is a 2, 3, 4. N of A is 2, N of B is 3. What about the N of A cross B? That's a 2 into 3. And then we'll have the 6 elements. Okay, number of the elements in the Cartesian product of AB, that is equals to 6. Next, Cartesian product of a set with itself. Okay, that's a स्वतःशीच Cartesian product करायचं. A cross A is equals to A square and that is equals to AB, where A comma B belongs to A. And here AB is an order pair. A cube means what? A cross A cross A, and that is A B C, where A B C belongs to capital A. ABC is an order triplet. Okay. Here A is equals to, in curly bracket 4, 5. Then we have A square, that is A cross A, that is a 4, 4, 4, 5. 5, 4, 5, 5. This is first one. And what about the A raised to 3? This here, A raised to 3 means what? A into A into A. Then what you will get? That is first is 4, 4, 4. Next is a 4, 4, 5. Okay. Next is again the 4, 5, 4. Or you can have there the triplets you can write here. What about the first element? The first element is a 4 and here is a 5. If you want to find out the triple product. Okay. Again this 4 will split up in this way. This is the 4 and here is a 5. And this 5 will split up like this, 4 and 5. Again this 4 will split up to 4 and 5. And this 5, 4 and 5. This 4, 4, 5. And this 5 again 4 and 5. If you want to find out the elements, what about the first order pair for this triple product? 4, 4, 4. 4, 4, 5. This is first one. Now here 4, 5, 4. 4, 5, 5 in this way. And from here you will get total 4 and from here 4. And total is 8. See this here. 1, 2, 3, 4, 5, 6, 7 and 8. What about here again? 5, 4, 4. 5, 4, 5. 5, 5, 4, 5, 5, 5. Okay, in this way. Now the next is a note that if n of a is m, then the n of a cross a cross a, that is equals to m raised to 3. Okay, that is a 2 raised to 3 means what? 8. Now next is a n of a cube is equals to n of a bracket cube. In general, n of a cross its r times, then you will get n of a raised to r. Okay. Now the next concept is the relation. This is also very important. The concept of the term relation is drawn from the meaning of relation in English language, according to which two objects or the quantities are related if there is a recognizable link between them. Okay, we are considering the two objects and there is a recognizable link between them. See this here. The members in a family are often related to each other. Okay. We describe the relation as A is a friend of B, F is a father of S, P is a sister of Q, in this way in a family. Okay. And what about in mathematics? In mathematics, we can have different relations. For example, among the integers, we can define the relation as, what is that? M is factor of n. If this relation is denoted by r, then we write, what is my relation? M is a factor of n. See this here. 2 r 4 means what? 2 is a factor of 4. What about the next? 3 r 6. 3 is a factor of 6. 5 r 10. 5 is a factor of 10 in this way. Okay. A well-defined relation between elements of A and B is given by in this way you have to denote it. What is that? A is related to B by using the particular relation, whatever that is. Maybe the factor is divisible by, or their subtraction is an odd number, and etc. etc. Yeah, prakare. Now here small a belongs to capital A and the small b belongs to capital B. Thus the relation gives the order pair AB and defines a subset of A cross B. It is always, that relation is always subset of this A cross B. Okay. For example, if I had the element in curly bracket 2, 3, 4, 5, 6 and B 6, 7, 8 and 10. Then the relation, that is A or B. What is that relation? A is a factor of B. A हा B चा factor पाहिजे. मग A मधला element घेणार आणि B मधला. What is that? 2 is a factor of 6. Yes, we have here. 2 is a factor of 8. Yes, I cannot take 2 and 7 because 2 is not the factor of 7. Okay. Next, 2, 10. That is a 2 is a factor of 10. Next, 3, 6. 3 is a factor of 6. Okay. 5 is a factor of 10 and in this way. Therefore, the 2, 6, 2, 8, 2, 10, 3, 6, 4, 8, 5, 8 of A cross B. Okay. All these pairs are the subset of A cross B. Okay. On the other hand, if we consider another subset, that is the S dash, and that relation is a 2, 7, 3, 10, 4, 7 of A cross B, then there is a unique relation R dash given by this subset. Okay. 2 is related to 7, that is a 2 R dash 7, 3 R dash 10, 4 R dash 7. Okay. Thus, S dash has defined in R. Okay. Now the next. For every relation between A and B, there is a unique subset defined in A cross B. That is always unique. जर A आणि B मध्ये एखादं मी रिलेशन डेव्हलप केलं आणि तो सबसेट हा या AB चा कसा असणार आहे? युनिक. इट इज ओनली द सिंगल वन. ओके. अँड फॉर एव्हरी सबसेट ऑफ A क्रॉस B, देर इज अ युनिक रिलेशन असोसिएटेड विथ इट. आणि कुठलाही सबसेट जर आपण त्याच्यातला घेतला तर त्या दोघांमधलं एलिमेंट्स मधलं फर्स्ट कंपोनंट अँड द सेकंड कंपोनंट मध्ये देखील एक युनिक रिलेशन असणार आहे. हेन्स वी कॅन से दॅट every relation between A and B is a subset of A cross B. Every relation between the A and B is a subset of always A cross B. And all relationships are order pairs in A cross B. And they are in the form of the A cross B. When A is equals to B, then what will happen? That is when we have the relation between the elements of A and will be the subset of A cross A. It is a subset of A cross A. Now, next is and this type of the A cross A is called the binary relation on A. That is a relation on itself. That is, if A is a non-empty, any relation, if small a is a non-empty, any relation in A cross A, and that is called the binary relation on A. That is a relation with itself. In that set, that is called the binary relation. Now let A is equals to 1, 2, 3, 4, 5 and B is a 1, 4, 5. Okay. Let R be the relation such that XY belongs to capital R. Implies that what type of the relation must be? That X is less than Y. म्हणजे पहिला एलिमेंट हा दुसऱ्यापेक्षा कसा असला पाहिजे? लहान असला पाहिजे. किंवा दुसरा हा पहिल्यापेक्षा मोठा असला पाहिजे. We list the elements of R. Okay. We list the elements of the R. Now A is 1, 2, 3, 4, 5 and B is 1, 4, 5. तर A मधला मी 1 घेतला तर मला रिलेटेड 1 घेता येईल की ते नाही. आपल्याला रिलेशन कसं पाहिजे की 1 is less than 4. 1 is less than 5. Therefore 1, 4, 1, 5. Next 2 आणि 1 घेणार का तर नाही घेणार. 2 is less than 4. Yes. 2 is less than 5. Okay. 3 is less than 4. 3 is less than 5. And what about the next? Next is 4 is less than 5 and in this way. This is the relation. What is that type we have defined here? It defines like this: X is less than Y. या टाइपचे relations. Okay. Arrow diagram for this relation R is given by. Normal arrow diagram आपण तिथे काढू शकतो इथे. A आणि B. A मधले elements आणि B मधले elements. Now this 1 is related to 4. Yes. That is 1 is less than 4. 1 is less than 5. 2 is less than 4. 2 is less than 5. 3 is less than 4. 3 is less than 5. And what about the 4? 4 is less than 5 in this way. Now the domain. The set of all first component of order pairs in a relation R is called the domain of the relation capital R. Okay. तर पहिला जो एलिमेंट असणार आहे प्रत्येक ऑर्डर पेअर मधला तर त्याला काय म्हटलं जातं? इट्स कॉल्ड दी डोमेन अँड वी कॅन डिफाइन इट लाईक दिस. A is such that A comma B belongs to set of real number. Okay. And what about the range? The set of all second component of order pair in a relation capital R is called the range of relation. Second component ला काय म्हणायचं? The range. And we can define range of R is equals to, that is the B particularly, where A comma B must be in R. Okay. This is the domain and this is the range. Now next, don't confuse between the range and the codomain. Now see this, what is meant by the codomain? If, what is here? R is a relation from A to B, okay, then set B is called the codomain of the relation R, okay. B is called the codomain of that relation, and always range is a subset of the codomain. Range is a subset of the codomain. Okay. And this is also important. Next, binary relation on a set. त्या सेटशी होणारा ऑर्डर पेअर, and that is called the binary relation. Let A be non-empty set, then every subset of A cross A is a Now we will start the exercise 5. Now the first example, if x minus 1 and y plus 4 is equals to 1, 2, find the values of x and y. Now the solution, since x minus 1 comma y plus 4 is equals to 1, 2, the corresponding elements are equal, therefore x minus 1 is equals to 1 and y plus 4 is equals to 2, and hence you will get x is equals to 2 and y is equals to minus 4. It's very easy example. Second, if x plus 1 by 3 comma y by 3 minus 1 is equals to 1 by 3 comma 3 by 2, find x and y. Now the solution, x plus 1 by 3 comma y by 3 minus 1 is equals to 1 by 3 comma 3 by 2. The corresponding elements are equal. Okay, and therefore x plus 1 by 3 is equals to 1 by 3, y by 3 minus 1 is equals to 3 by 2. 1 by 3 on both sides gets cancelled. You will get x is equals to 0. Y by 3 is equals to 3 by 2 plus 1. 3 by 2 plus 1 means what? It is a 5 by 2, and hence the value of x and y, x is 0, y is a 5 by, therefore y is equals to 5 by 2. It's very easy example. Example number 3, if a is abc, b is, now the question number 3, I will repeat again. Okay, a is abc, b is xy, then find a cross b, b cross a cross a, b cross b. Okay, a is abc, b is xy, a cross b is abc, okay, then xy. Then what are the elements? Ax, ay, bx, by, cx, cy, in this way. Then the b cross a, that is a xy cross abc. Then you will get xa, okay, xb, xc, then ya, yb, yc. A cross a, abc cross abc, aa, ab, ac. Then BA, BB, BC. Next is a CA, CB and the CC in this way. B cross B, that is a XY cross XY. Then you will get XX, XY, YX, YY in this way. Okay, all are the easy. Now the next is, you can see this. Question number 4. If P is 1, 2, 3, Q is 1, 4, find the set P cross Q and Q cross P. P is 1, 2, 3, Q is 1, 4. P cross Q is 1, 2, 3, cross 1, 4. 1, 1, 1, 4. 2, 1, 2, 4. 3, 1, 3, 4. Okay. Q cross P. 1, 4, cross 1, 2, 3. 1, 1, 1, 2, 1, 3. 4, 1, 4, 2, 4, 3. In this way. This is the Q cross P. Okay. Now the question number 5. Let A is equals to, in curly bracket, 1, 2, 3, 4, B is 4, 5, 6, C is 5, 6. Verify that A cross, in bracket, B intersection C is equals to A cross B intersection A cross C. Okay. And next is A cross, in bracket, B union C is equals to A cross B union A cross C. Now this is the set A. Now then we'll find out the B intersection C. That is a common element, which is the 5 and 6. Now A cross B intersection C is A is 1, 2, 3, 4, B is 5, 6. Okay. Then 1, 5, 1, 6. 2, 5, 2, 6. 3, 5, okay, and 3, 6. 4, 5, 4, 6. This is number 1. Okay. Now next is we want to find out the A cross B and then A cross C and their intersection. Now A cross B, A is 1, 2, 3, 4, B is 4, 5, 6. 1, 4, 1, 5, 1, 6. 2, 4, 2, 5, 2, 6. 3, 4, 3, 5, okay, and 3, 6. Okay. 4, 4, 4, 5, 4, 6 in this way. Now next is A cross C. 1, 2, 3, 4 cross 5, 6. 1, 5, 1, 6, 2, 5, 2, 6, 3, 5, 3, 6, 4, 5, 4, 6 in this way, A cross C. Now the intersection of A cross B and A cross C. Okay. Now, which are the common element? Is there 1 4? 1 4 is not there. 1 5. Yes, this is the 1 5. Next is a 1 6. 1 6 is here. 1 6. Okay. Next is a 2 5. 2 5 is here. 2 5. Next is a 2 6. Here is a 2 6 and 2 6. 3 5. Okay. And here is a 3 5. 3 6 3 6. 4 5 4 5. And last is a 4 6. And in this way, we have the A cross B intersection A cross C. Okay. And this is the number 2. And this is number 1. And therefore, from 1 and 2, see this here, number of the element 1, 2, 3, 4, 5, 6, 7, 8. Okay. And how many are there? 1, 2, 3, 4, 5, 6, 7, 8. Their numbers are same and the elements are also same. 1, 5, 1, 6, 2, 5, 2, 6. 1, 5, 1, 6, 2, 5, 2, 6 in this way. 3, 5, 3, 6, 4, 5. And hence, from 1 and 2, we have A cross in bracket B intersection C is equals to A cross B intersection A cross C. And hence the results. Now, second one, A cross in bracket B union C is equals to A cross B union A cross C. Now, A is 1, 2, 3, 4. Next is a B union C. That is a 4, 5, 6 union 5, 6 means what? 4, 5, 6. A cross in bracket B union C. That is 1, 2, 3, 4 cross 4, 5, 6. Okay. And here we have the elements. That is 1, 4, 1, 5, 1, 6. 2, 4, 2, 5, 2, 6. 3, 4, 3, 5, 3, 6. 4, 4, 4, 5, 4, 6. In this way. Okay. And this is the A cross in bracket B union C. Next is A cross B. Okay. A is 1, 2, 3, 4 and B is 4, 5, 6. Therefore 1, 4, 1, 5 and next is 1, 6. 2, 4, 2, 5, 2, 6. 3, 4, 3, 5, 3, 6. 4, 4, 4, 5, 4, 6 in this way. This is the A cross B. Okay. And the next is A cross C. That is A is 1, 2, 3, 4 and B is 5, 6. Okay. Then you will have 1, 5, 1, 6. Okay. 2, 5, 2, 6. 3, 5, 3, 6. 4, 5, 4, 6. In this way, this is the A cross C. Now their union. A cross B union A cross C. Okay. And the union of all these is equals to, okay, 1, 4. You can take this union. That is a 1, 5, 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, 3, 6, 4, 4, 4, 5 and the 4, 6. Okay. And therefore from 1 and 2. If we observe here, the 1, okay, that is A cross in bracket B union C. This is the number 1. Okay. And the last is a number 2. Okay. This is the number 2. And these two are equal. You can verify this. This is first one, second, and this is the first and second. These are the equal. Now the next question. Express xy such that x square plus y square is equals to 100, where xy belongs to W as a set of ordered pairs. Okay, now the solution. We have to find xy such that x square plus y square is equals to 100, where x comma y belongs to W. First, x is equals to 0, y is 10. Okay. Then x square plus y square is equals to 0 square plus 10 square, that is equals to 100. X is 6, y is 8, that is a 6 square. X square plus y square, 6 square plus 8 square. Then this is a 36, 64. Then you will get 100. X is 8, y is 6. Okay. Therefore, x square plus y square is 64 plus 36. Then you will get 100. X is 10, y is 0. X square plus y square, that is 100 plus 0. Then you will get the 100. Now the given set is first का असणार आहे 0, 10, 6, 8, 8, 6, 10, 0 in this way. Okay. Now the next question number 7. You can see this once again. पुन्हा तुम्ही हे बघू शकताय. Okay. Now the next question. Let A 6, 8, B 1, 3, 5. Show that R1 is a relation such that A comma B, A belongs to A, B belongs to B, A minus B is an even number, is a null relation, and the R2, where is A comma B, A is in A, B is in B, A plus B is odd number, is and the universal relation. Okay. Now here A comma A belongs to capital A, B belongs to capital B, A is even, B is odd. Okay, and their subtraction is always odd number, and hence there is no element in R1. That is, R1 is an empty relation from A to B. Okay, this is the first one. Now next, if A belongs to capital A, B belongs to capital B, A is even, B is odd. One even and another is odd. Their total is always odd. Okay, and therefore A comma B belongs to set of the real number. R2 मध्ये आपल्याला तो नंबर कसा पाहिजे, that is A plus B is odd number. Okay, and hence here A plus B is odd, and that is A plus B belongs to R2 for all A belongs to A, B belongs to B, and hence R2 is an universal relation. Okay, R2 is a universal relation. Next, question number 8. Write the relation in the roster form. State its a domain and range. Okay. R1, A comma A square, A is a prime number less than 15. R1, A comma A square, A is a prime number less than 15. The prime number less than 15 are 2, 3, 5, 7, 11, 13. What about the R1? R1, म्हणजे first is 2, 2 square is 4, 3, 3 square is 9, 5, 5 square is 25, 7, 7 square is a 49, 11, 11 square is a 121, 13, 13 square is a 169. Domain of R1. A is such that A is a prime number less than 15. Okay, A is a prime number less than 15. That is a 2, 3, 5, 7, 11, 13. And the range of R1. Okay, 4, 9, 25, 49, 121 and the 169. Okay, in this way, so find out the domain and the range for the R1. Easy question hai to. Next, R2. A comma 1 upon A. The values of A lies between 0 to 5 and equal to 5. A belongs to set of a natural number. Now R2 is the relation A comma 1 upon A such that the value of A lies between 0 to 5 and equal to 5. A belongs to set of natural number. Now first is R2. That is the first is 1, 1. We can take the value of A is 1, 2, 3, 4, 5. 1, 1. नंतर मग A ची व्हॅल्यू जर आपण 2 घेतली, then 2, 1 upon 2. A ची व्हॅल्यू 3, 3 and 1 upon 3. Because the relation is A and 1 upon A. 4, 1 by 5. 5, 1 by 5. In this way. This is the R2. That is now the domain of R2. What is the domain of R2? Domain of R2 is 1, 2, 3, 4, 5. First element. And what about the range? Range is the reciprocal of this A. That is 1, 1 upon 2, 1 by 3, 1 by 4 and 1 by 5. This is the range of R2. Easy question hai to. Okay. Now the third one, R3. Xy such that y is equals to 3x, y belongs to 3, 6, 9, 12, comma, x belongs to 1, 2, 3. Now the solution. Okay. R3 is xy such that y is equals to 3x, x belongs to 1, 2, 3, y belongs to 3, 6, 9, 12. Okay. Now what type of this relation is a y is equals to 3x, x belongs to 1, 2, 3, y belongs to 3, 6, 9, 12. If you take x is equals to 1, okay, then y is equals to 3 into 1, then you will get 3. X is equals to 2, y is equals to 3 into 2, then 6. X is equals to 3, y is equals to 3 into 3, that is a 9. Then what is the relation here? 1, 3, 2, 6, 3, 9 in this way. Okay. Now the next is a domain of R3. Domain of R3 is a 1, 2, 3. That is the first element of the order pair. Range of R3, second element, that is a 3, 6, 9. Easy questions. Okay. तुम्ही पुन्हा एकदा बघू शकताय. Okay. Now the next R4. XY is such that y is greater than x plus 1. X is equals to 1 2, y is equals to 2 4 6. R4. XY is such that y is greater than x plus 1. X is equals to 1 2 and y is equals to 2 4 6. Here y is greater than x plus 1. X is equals to 1 2, y is equals to 2 4 6. If we take x is equals to 1, okay. If we take first of all x is equals to 1, then 4 is greater than 1 plus 1. इथे 2 नाही घेता येणार आपल्याला, म्हणून डायरेक्ट काय घेणार आपण, तर 4 घेणार. 6 is greater than again 1 plus 1, and hence the first is a x is equals to 1, then you will get 4 and y is equals to 4 and y is equals to 6. If you take x is equals to 2, okay, then 4 is greater than y is equals to y is greater than x plus 1 दिलेला आपल्याला त्याने. That is, if we take again from the y 4 is greater than 2 plus 1, 6 is greater than again 2 plus 1, that is y is equals to 4 and y is equals to 6 here, okay, when x is equals to 2, okay. Therefore we have the R4 relation. पहिला बघा इथे 1 घेतलं असताना काय ना 1 4 1 6 1 4 1 6. For the second 2 4 2 6 2 4 2 6. Domain of R4. The set of first element of order pairs. First element 1 2, okay, 1 2, and the range of R4 4 6. Range of R4 is a 4 6 in this way, okay. Easy question again. Now the R5. XY such that x plus y is equals to 3, where x comma y belongs to 0 1 2 3, okay. X plus y, that is equals to 3, where xy belongs to 0 1 2 3. If we take x is equals to 0, then y is 3. X is 1, y is 2. Their total is always 3. X is 2, y is 1. X is 3, y is 0 in this way. Okay, and therefore the R5. R5 का है ना 0 3 1 2 2 1 3 0 in this way. This is the R5. Okay. Now the next domain of R5. Set of first element of order pairs of R5 0 1 2 3. Okay. Range of R5, that is the second element of R5, that is the 3 2 1 0, means what, 1 2 3 0. This is the R5. Next, what's the relation? R6. कसा है R6? A comma B, where A belongs to set of natural number. A is less than 6 and B is equals to 4. It's constant only. Okay. A comma B, A is in set of natural number such that, okay, A is less than 6 and B is equals to 4. A is less than 6 and A belongs to set of natural number, means what? You will get 1 4. B constant hai, B is 4. A is less than 6 means what? You will get 1 2 3 4 5. 1 4 2 4 3 4 4 4 5 4 in this way. Therefore now the domain of R6 is a 1 2 3 4 5. 1 2 3 4 5. Range of R6 is only single element, that is a 4. Okay. Now the next is a R7. A comma B, such that A comma B belongs to set of natural number. A plus B is equals to 6. Now this is the R7. A plus B ची total किती आली पाहिजे? 6 आली पाहिजे. आणि AB belongs to set of natural number. If I take A is equals to 1, B is equals to 6. Sorry, 6 minus 1, that is 5. And therefore, first is 1 5. A is 2, then B is 4. A is 3, B is 3. A is 4, B is 2. We will take the value of A and B such that their sum is equals to 6. Okay. Then I will have the order pair 1 5 2 4 2 3 3 4 2 5 1 in this way. Now the domain of R7. Set of first element of order pair of R7, that is 1 2 3 4 5. 1 2 3 4 5. Second, this is the domain of R7. Range of R7, that is a set of second element of order. Okay. that is a 5, 4, 3, 2, 1. We can write it like this or keep it like this also. 5, 4, 3, 2, 1 or 1, 2, 3, 4, 5. Okay. This is the range of R7. Okay. Now next question R8. R8 is the relation AB such that B is equals to A plus 2. A belongs to Z. That is a set of integers. And the value of A lies between 0 to 5. Okay. B is equals to A plus 2. B is equals to A plus 2. Value of the A lies between 0 to 5. That is, we will take the values of A. They are 1, 2, 3, 4. Okay. Now the first is, if I take A is equals to 1, then what about the B? B is 1 plus 2, that is a 3. If I take A is equals to 2, then B is a 2 plus 2, that is a 4. If I take A is equals to 3, then B is a 3 plus 2, the 5. If I take A is equals to 4, 4 plus 2, then you will get 6. Then what is the domain of R8? The domain of R8 is a 1, 2, 3, 4. This is the domain of R8. And what about the range of R8? Range of R8 is a 3, 4, 5, 6. This is the range of R8 in this way. Okay. Now the next question. This is also very important, or it is activity question. तुम्हाला किती समजलं? The following relations are the reflexive, symmetric and the transitive. Actually ते अवघड आहे, परंतु हे जर समजलं तर तुम्हाला reflexive, symmetric and the transitive हे clear तुम्हाला तिथे समजू शकते. Okay, what is the first? R is a relation AB. A comma B belongs to set of integer. A minus B is an integer. Okay, now this is R. A comma B belongs to Z. A minus B is an integer. No problem. A, B, C belongs to Z. A minus A is 0, belongs to Z. Therefore, A R B for every A belongs to Z. That is R is a reflexive. A R B, then A minus B is an integer. If I give here minus sign, minus of A minus B, that is nothing but the B minus A. B minus E is also integer. And hence, BRA, that is the ARB implies BRA. ARB is integer. It implies that B minus A means what? BRA. Okay. Therefore, ARB implies BRA for every A comma B belongs to Z. ARB means what? A minus B is an integer. BRA means what? B minus A is an integer. And hence, ARB implies that BR is also integer. Okay. Therefore, here we say that R is a symmetric. Okay. Next, ARB and the BRC. ARB means what? A minus B is integer. BRC means what? B minus C are the integers. If you add these two, that is A minus B plus B minus C, then you will get plus B minus B get cancelled. You will get A minus C is an integer. And hence, ARB comma BRC implies that ARC for every ABC belongs to Z, and hence R is a transitive. Now the next, R is A comma B such that A comma B belongs to set of natural number. A plus B is even. ABC belongs to N. Next is A plus A, that is equals to 2A. A 2A number is always even because it is multiplied with the 2. Therefore, ARA for every A belongs to set of natural number. R is a reflexive. Okay. Next, ARB means what? A plus B is even. B plus A is even. Okay. A plus B even असेल, the B plus also even. As B plus A is even, then we can write it like this, BRA. Okay. बघा आपण सुरुवात काय करतो? Let we have the relation ARB. It implies that A plus B is even. A plus B even आहे, तर मी हे कसं लिहू शकणार आहे? B plus A is also even. But B plus A रिलेशनच्या भाषेत कसं लिहिणार? BRA. And it implies that as the ARB is even, it implies that BRA is also even for every A comma B belongs to set of natural number. म्हणून हा एक प्रकारचा अल्जिब्रा आहे. यामध्ये कन्सिडरेशन इज इम्पॉर्टंट. हे कन्सिडरेशन आहे, तर मी हे असं लिहिणार. हे मला असं लिहिता येईल, पण याचा अर्थ काय होतो? BRA. BR is okay. And hence ARB implies BRA for every A comma B belongs to set of natural number. And hence R is a symmetry. आता पुन्हा ARB and BRC. ARB means what? A plus B even. BRC means what? B plus C is R even. A plus B is even means what? That is a 2 into n. म्हणजे तो even number आहे. B plus C is equals to 2n. If I add it, then you will get A plus B plus C, and that is equals to 2m plus 2n. Okay. Again, this can be written as A plus B plus B plus C. That is A plus C can be written as this B plus B. That is a 2B. आपण तो shift करणार right hand side ला. It will become minus 2B. It means that A plus C is equals to 2m plus 2n minus 2b, and that is nothing but a 2 in bracket m plus n minus b is the even number. Okay. तर हा काय तर तो even number आहे, and it implies that ARC. It implies the relation ARC. कोणते दोन रिलेशन कन्सिडर केले होते आपण? ARB, then BRC. It implies that ARC means what? This is the transitive relation. That is the ARB is the even, BRC is even. It implies that ARC is also even for every ABC belongs to set of natural number. Then hence R is a transitive. Next is a R is a relation A comma B. A comma B belongs to set of natural number A divides B. Now see this here. जर आपण A घेतला, A divides A, then ARB for every A belongs to set of natural number. R is a reflexive. Now next, if I take A is equals to 2 and B is equals to 4, it means that 2 divides 4. Yes. So we can write ARB. But 4 does not divide 2. That is a 4 does not divide the 2, and therefore ARB is not equals to BRA, and hence R is not symmetric here. This is important. ARB, yes, that is a 2 divides 4. But what about the BRC? 4 does not divides 2. We get the fraction there. Okay. Now next, ARB comma BRC means what? A divides B. BRC means what? B divides C. A divides B means what? B is equals to M. Next, B divides C means what? C is equals to Bn, where M comma N belongs to set of natural number. What about the C? C म्हणजे काय? The Bn. Substitute the value of B. B is AM. Therefore, C is equals to AM into N. That is A in bracket M into M. That is C is equals to A in bracket M into N. It means that A divides C, that is a ARC. आता याचाच अर्थ काय की A हा B ला डिवाइड करतो, B हा C ला डिवाइड करतो. It means that A divides C for every ABC belongs to set of natural number, and hence it is a transitive. Now the next is AB. Next relation A comma B is such that A is a sister of B. Okay, A is a sister of B. Next is A comma B belongs to G, and G is a set of the girls. मग ARA आपण लिहू शकणार का याच्यामध्ये? Sorry, this is R. ARA, that is A is a sister of A. That is no girl is her own sister. That is ARA for every A belongs to G. Therefore, R is not reflexive. प्रत्येक गर्ल ही स्वतःची सिस्टर असणार आहे का? तर नाही. Next is ARB. Okay, means what? A is a sister of B. What about the next? B is a sister of A. Yes, ते चालेल मला. ARB means what? A is a sister of B. हेच कसं लिहिता येईल आपल्याला? B is a sister of A. Means what? As B is a sister of A कसं लिहिता येईल? BRA. It means that ARB implies that BRA, and hence the R is a symmetry for every A comma B belongs to G. Next, ARB BRC म्हणजे A ही B ची सिस्टर आहे, B ही C ची सिस्टर आहे. It implies that A is a sister of C. A is a sister of B. B is a sister of B is a sister of C. It implies that A is a sister of C. That is a ARB comma BRC implies that ARC for every ABC belongs to G. Then R is a transitive. Okay. Now the next relation, 6-1, R is equals to, in bracket, A comma B. Line A is a perpendicular to line B in a plane. Okay. Again, I will repeat here. R is a relation A comma B such that line A is a perpendicular to line B in a plane. No line is a perpendicular to itself. Therefore, I will write here A, R, A for any line, okay, is not reflexive. Okay, no line is a perpendicular to itself. Okay, therefore, this relation is not reflexive. What about the next? A, R, B means what? A is a perpendicular to B. It's clear that B is a perpendicular to it. Means what? B, R, A, and hence A, R, B implies B, R, A for every A comma B belongs to, for every line A comma B belongs to the set of the line in that plane. Okay, and hence R is a symmetric there. Okay, next, if A is a perpendicular to B, B is a perpendicular to C, then it is A is a parallel to C. Okay, if I take the line like this is the A. A is a perpendicular to B. This is, I take B. Okay, one must draw the arrow. A is perpendicular to B. Okay, and B is a perpendicular to C. Then I will draw here the another line C. It means that A and C are parallel. Therefore, similarly here, A is a perpendicular to B, B is perpendicular to C, then A is a parallel to C, and therefore ARB, if ARB is there, BRC is there, which is not equals to ARC, and hence that is ARC is not possible. Therefore, R is not the transitive. Okay, yeah. So tomorrow they detail. Next is a seventh one. This is R, A comma B, such that A comma B belongs to set of real number and A is a less than B. Okay. आता first बघा, if I take the number A, every number is not less than itself. For every A belongs to set of real number. Therefore, R is not reflexive. Next, if I take A is equals to 2, B is equals to 4, then it's clear that A is less than B. Then the ARB relation holds. But what about this? If BRA म्हणजे B हा A पेक्षा लहान असणार आहे? Yes, it is not possible. And therefore BRA is not possible. And hence ARB is not equals to BRA. Okay. And hence R is not symmetric. What about the next? ARB. Okay. That is A is less than B, B is less than C. Okay. Then this is possible. A ha B पेक्षा लहान आहे, B ha C पेक्षा लहान आहे. It implies that A is less than C. That is a ARC. And therefore, ARC for every ABC belongs to set of real number. Okay. And hence, R is a transitive. Next. Eighth one. R is equals to, in curly bracket, A comma B, where A comma B belongs to set of real number, and A is equals to B cube. Okay. If I take A is equals to -2, then what about the A raised to 3? A raised to 3 is a -8. A raised to 3 is a -8. Then but -2 is a greater than -8. But this is not possible. Therefore, A is not less than or equal to A cube for all A belongs to set of real number, and hence R is not reflexive. If I take A is equals to 1 and B is equals to 2, so that A cube is 1, B cube is 8, then I will have the relation A is less than B cube, that is ARB. But B is greater than A cube, therefore B RA is not possible, and hence ARB is not equals to BRA. R is not symmetric. If I take A is equals to 8 and B is equals to 2, C is equals to 1.5, then what about the A is equals to B cube? ARB. Okay. C is equals to 1.5. That is 1.5 cube means what? 3.375. That it implies that B is a less than C cube. Okay, B is a less than C cube. That is the BRC is also there. But what about the A? A is 8. Okay, 8 is a greater than C cube. The value of C is a 3.375. A is a greater than C cube, and hence the R is not the transitive. Okay, R is not the transitive. This is not the possible. If ARB is a possible, BRC is a possible, but this is not the possible. ARC is not possible. ओके, या टाईपचे क्वेश्चन्स फार रेअरली परीक्षेला विचारले जातात. हा ऍक्टिव्हिटीचा प्रश्न आहे. तुम्हाला प्रिपेअर करायचं असेल तर तुम्ही ते करू शकताय. ओके, आणि ते तुमच्या त्या भाषेत तुम्ही ते लिहू शकताय. ओके, नाव इन दिस वे आय हॅड कम्प्लीटेड दी exercise 5.2. Now we'll see in the next video. Till then, goodbye.